All right, we're going to start notes here by doing a couple examples of counting subatomic particles in a nuclide. So all you have to know, if given an atom, say it's a silicone, and then you're given the mass of that atom too, let's say it's a 29, you need to look up silicone on the periodic table. You need to give me its symbol. You need to put that mass top left. You also need an atomic number bottom left. So silicone is number 14. You'll have to use your planner for that periodic table, or possibly the back cover of a book, or maybe you can see it up on the wall in the classroom, but you always have to know what the atomic number is and you have to look that up. But once you have this information, you're supposed to be able to tell me how many protons, neutrons, and electrons are in that atom. So in this silicone, I know that there are 14 protons because that's the whole point of an atomic number. That tells me how many protons there are automatically. But then, in order to figure out how many neutrons there are, I subtract those two numbers, which gives me 15. Right? Your mass number is your protons plus your neutrons. Your two nucleons are the only things that contribute to that mass overall. And then finally, electrons. Since this is a neutral atom, since I didn't tell you that the silicone had a charge, you just assume that there's the same number of positives and negatives. So if there's 14 protons that are positive, there have to be 14 electrons that are negative as well. So again, this shouldn't really be too hard. You did this in biology, right? All you have to do is use a couple of different things, a couple of different numbers off your periodic table to figure out what's what. So that was silicone. We can do another example real quick just to make sure we know what's going on. Let's say I have an argon isotope that has a mass of, let's say it's like 41, right? So I look it up on the periodic table. Symbol is AR. You have to give me the symbol again, right? You can't choose to not give me that because I'm actually giving you points for that on a quiz. Mass number goes top left, that's 41, and argon happens to be number 18 on the periodic table. And again, I'm just making that red for reference. But the number of protons is the number that's in red there. So I definitely have 18 protons. Neutrons, I'd subtract 18 from 41. Again, you might be able to do that in your head. This is actually going to be 23 neutrons. And electrons, since it's neutral still, definitely has to be the same as protons. Positive and negative cancel out. Definitely going to have the same number of protons and electrons in this case. So those are neutral atoms. We also have charged atoms. So if I had an example there, maybe I'm going to have magnesium 25. But magnesium is a metal, it tends to lose electrons, so let's give it a charge of +2, right? So if I give you a charge, the only thing that changes, I still got to look things up on the periodic table. I still need to put the mass number and the atomic number where they belong. So magnesium's number 12. But when it's all said and done, the only thing that's different now, I still have 12 protons. I still subtract two numbers to get neutrons, and it's going to be 13, 25 minus 12. But the electrons is where things change this time. In order to figure out how many electrons I have, right, one of the tricks that you can do, you can take your number of protons and you can subtract the charge from those protons. So logically speaking, if I'm going to have a positive charge, I have to have more positive things than negative things. So when it comes to electrons here, I need to have more protons than electrons. I need to have two more protons than electrons. So in order to figure out how many electrons there should be, I subtract 2 from my protons. And that should give me a 10. So I need 10 electrons, 2 less than the protons. That's why I end up with a positive 2 charge. Every time you do one of these examples, though, you should always just double check your work. It's not really hard to figure out if you logically have the right answer. If you have more electrons than protons, it's going to be negative, not positive. So just double check every time, make sure that you did it right. But if you subtract the charge from your proton number, that will typically give you the right answer. So I'll do one more example here. This time I'll have, let's go with a phosphorus example. Oops, should spell that right. And it's phosphorus, let's call it a 31. Right, so I need all the same things as always. Phosphorus happens to be a number 15 on my periodic table. Again, the 15 just tells you how many protons there are, so I already know that. Neutrons, I subtract my protons from my mass, and that's going to give me a 16 in this case. Electrons, again, I'm just going to subtract the charge. So this time, right, and I forgot to give it to you, phosphorus has a -3 charge, right? If the charge is negative and you're subtracting from your protons, if you subtract a -3, you're really adding 3, which should make sense because I need an answer of 18 that is bigger than 15. If there are more negatives than positives, that's what gives you a negative charge to begin with. So you can think about subtracting the charge, or you can just think about logically which one do I need to have more of and how many more do I need to have. But either way, if you can figure out how many electrons there are for that charge, that's all that matters. So at this point, your sub can give you your worksheet to practice this stuff. You have to turn that in, and then you're going to work on another worksheet with a simulator online. So just work productively, get all that stuff done before Wednesday, and we should be good.